Hello, welcome to Linear Model. My name is Sarini Abdullah, the lecturer for this course. For this week, we will learn about the model assumption consists of four assumptions for the error. That is, first is zero mean assumption. The second is about the normal distribution assumption. The third assumption is about the constant variance, and the fourth assumption is about independency between errors. Let's start by looking at the model. So we have the general form of the model can be written like this formula that for observation I, for example, let's say we have a sample of size n. So for the eighth observation, we have the relationship that yi equals beta naught plus beta 1 xi plus epsilon I. And we have the assumption for each of the error term for each observation or for each I is normally independent, identically distributed with the mean of 0 and the variance of sigma squared. And the variance does not have the index I, it means it's a constant variance, the same for all I from 1 to n. Now let's look about the zero mean error. The zero mean error, we will do the illustration using this hypothetical data. Let's say we have data like this, and then we are about to fit a regression line to this data. Of course, we want the line to be the best line. By the best, we mean that it will give us the most accurate prediction that will and also can resemble the relationship between the independent and the dependent variable. Let's say we have this line. Is this the best line? Let's see. Let's say we want to use this line to predict the value for other x in the data. So here, for the first value of x, we have 3 observations. And then for the first observation, we can have the prediction is exactly on the line, so it is 0 error. But then for the second prediction, we have this much error. And then for the third observation, that having the same value, we have this much error. And the error is the difference between the predicted value here and the true value, the true observed value. So in this case, we have the sum of error for this setup value of x is negative, because here we have 0 error, negative error, another negative error, so the total of the error for this value of x is negative. Similar thing happens for the value of x equals 2. We also have negative error for the second value of 2 and also negative error for the third value of 2. So in total, for this design or this setup, we have the same of error. The sum of error is negative, and the same thing also here for the last value of x. We also have negative error. So in this case, we say that the errors are negative. It means that the model is not good enough. Let's say we change it. We try to fit another line to our data. Let's say we have something like this. So it can predict accurately for this group of data, but it cannot accurately predict these groups of data. Let's see the error. So here we have positive error on the opposite to the previous example. And then we also have another positive error. So in total, we have a positive error for this setup value of x. The same thing also applies here, and also for the third value of x, we also have positive errors. So in total, the errors for all observations, they will give us positive errors, and we don't want this line either. We want it to give us the error that is as close as possible to 0. Now let's try to find another line. Let's say we have a line like this. This line doesn't pass through either one of the points, but we can see here the error with the first observation is like this, with the second observation is like that, and with the third observation is like that. So we can see that, let's say here, positive error over here, negative error over here, the magnitude of the errors, the positive and negative are the same, so we have that the sum of error equals 0. For just this one setup value of x. Now we move on to the next setup value of x equals 2. There are 3 observations here. The line does not pass either one of these observations, so there's an error from the line in predicting the first observation with the x equals 2. There's also an error when predicting the second observation with x equals 2. There's also an error when predicting the third observation with x equals 2. But then, positive errors, negative errors, they cancel out, they give us the sum of error equals 0. And the same thing also applies here for the third value of x with 3 observations in there. They will give us the sum of error equals 0. So in this case, this is what we want to have. The sum of error for each different setup value of x equals 0. So then, in total, the expectation of the error, which is we can approximate by the average of the error in the whole data points. In here, it means that we have 9 data points, so 1 on 9 times the sum of the total error in these 9 data points, we will expect it to be 0, which means that the line that we get should be the candidate. It doesn't guarantee it's the best line by just this assumption, but it guarantee that the best line should fulfill the first assumption that the expectation of error equals 0. And to get this assumption to be fulfilled, we would fit a line that will pass through as close as possible to each data point, and if that is not possible, then we will try that our line to be in the middle of the data points. So that's what is meant by the zero mean error.